Question 9. Two summer resorts offer private lessons for their customers. First resort charges $5 per hour plus $40 insurance. Second resort charges $10 per hour plus $30 insurance. For what number of hours is the cost of the lessons the same for each resort? Blank hours. So, first of all, we need to do two systems. So the first one is going to be green. The second one is going to be blue. So the first resort is green, and that charges $5 per hour plus $40 insurance. So $40 insurance is never going to change, plus $5 per hour, so 5x, and that would equal the total. So that's my blue equation. The blue equation, the second resort, charges $10 per hour plus $30 insurance. So how would I write that? That one's easy too. Y equals, my insurance is 30 plus 10x. So for what number of hours is the cost of lessons the same for each resort? So we need to solve for x. Well, there's an easy way to do this. Substitution. So cloud this up. And what does the cloud equal? The cloud equals y. So let's replace this and substitute it for the y in the green one. So replace it here. So let's do that. I'm going to rewrite this new equation. So, 30 plus 10x equals, and what's it going to equal? 40 plus 5x. Now I simply solve this. Okay, there are two like terms right here and right here. And then there are two like terms right here and right here. So I need to get my circles together and my boxes together. So how do I move this circle to this circle? Remember, draw a line, subtract 5x, subtract 5x. I can cross out these 5x's and drop down 10 minus 5. 10 minus 5 is 5x. It's a positive, so it's positive. Drop down my 30. Drop down my 40. Drop down the equal sign. Okay, got two more steps. Subtract 30 from both sides. I can cross out these 30s. Drop down the 5x. Equals 40 minus 30 is 10. Simply now, just divide. What does x equal? X equals 2. So 2 is the answer. Okay, pretty easy substitution problem. We should not get hung up on this. All right, let's move on to number 10. Remember, you can always pause the video at any time to slow it down. Okay, the next one. The Elkins family found an extra $120 to buy tickets to the football game this weekend. The following graph represents the number of students and number of adults that can attend the football game for $120. So, what is the meaning of the y-intercept? All this is a plug-in. So the y-intercept shows the number of blank. So you have a 50-50 shot. Is it the adult tickets or the student tickets? So we got to remember, where is the y-intercept? The y-intercept is on what axis? It says it right there. What does the y-intercept represent? So the y-intercept is 6. And look, guys, it even tells you it stands for adult tickets. So the y-intercept shows the number of adult tickets sold when the number of blank either adult or student tickets is 0. So this point right here is 6 and what? It's 6 and 0. So how many student tickets are sold? 0, but 6 adult tickets. So this answer is students. Okay, what is the meaning of the x-intercept? So the x-intercept shows the number of, so the x-intercept is not this anymore, it's the opposite. It's this point. So that's the x-intercept. That is the y-intercept. So what does this represent? Well, this represents the number of student tickets. It says it right here. So the x-intercept shows the number of student tickets sold when the number of blank tickets is 0. So when the students is 12, how many adult tickets? 0. So adult tickets is this answer. Okay. From the graph, we know the price of each adult ticket is blank and the price of each student ticket is blank. Alright, so let's see. The Alkins family found an extra $120 to buy tickets for the football game this weekend. The following graph represents the number of students and number of adults who can attend the football game for $120. So if I do 120 and I divide it by 6, which is my y-intercept, I can determine how much my adult ticket is. So that adult ticket is $20. So from the graph, we know the price of each adult ticket is $20. Well, where did I get the 120 from? It says it right here. This graph represents the number of adults and students who can attend the game for 120. Okay, now how do I figure out how much for 12 for students? So 120 this time by 12, and that should be 10. Okay, so pretty easy question as well. We just got to know what to do. Again, there's going to be a problem just like this on the test. Just follow along what I do. You just replace the numbers. Okay? Alright, let's move on to 11. Line L is shown on the coordinate plane below. Which statement is true about line L? Okay, the slope is less than 0 and the y-intercept is greater than 0. Alright, so let's see. Well, what is my slope? Here's a point and here's another point. So how much did I rise up from here? So I run 1, 2, 3. So this is 3 and I run up 2. So this slope is 2 over 3. Now what's my y-intercept? My y-intercept is 1. So my b equals 1. So the slope is less than 0 and the y-intercept is greater than 0. Well, 2 over 3 is less than 0. Okay, let's read these other ones. The slope is less than 0 and the y-intercept is less than 0. Well, no, my y-intercept is greater than 0. So this is wrong. And A is correct so far. The slope is greater than 0. Well, no, we don't. That's not true. The slope is greater than 0. That's also not true. So A is the correct statement. Let's move on to 12. The following graph represents the system of inequalities. Which points are solutions to the system? Alright, so this was our last lesson that we talked about. So just to clarify, the dark area, this area that I'm highlighting right here, are the solutions to this problem. The overlapped areas are the solution to the problem. So all this yellow is the solution. So let's figure this out. So is 4 and 0 in the yellow? So let's see. 4 is x, y is 0. So 4 and 0 is right here. And yes, that is a solution, so yes. What about negative 2? So remember, x goes first, negative 2 and positive 2. Well, that's right here. So yes, that's in that yellow. 0 and 3. So 0 and 3. Well, here's the tricky part about this. You see how it's on the dotted line? Since it's on the dotted line, it is no. So dotted, if it's on, so I'll write that. If it is on a dotted line, it is not a solution. If it is on a solid line, it is a solution. Okay? So dotted lines means the number is not included. Solid lines means the number is. Be careful with that. They're going to try and throw you off. So I would write that down. This is big points right here. All right, next one. 1 and negative 3. So 1 on the x-axis and negative 3. That is not in the yellow, so this is a no as well. 0 and negative 1. So 0 and negative 1. Sorry, that was not 0 and negative 1. 0 and negative 1. Okay, it's on the solid line. So what did we just put? If it is on the solid line, it is a solution. So this is a true statement. And 3 and negative 1. So 3 on the x-axis, go down to negative 1. Once again, it's in the dark area, so yes. Okay, very easy one too. We need to get these correct, guys. All right, let's move on to 3. Which inequality are shown on the graph? Find your inequality in the grid below. Check the one box that pairs the two correct inequalities. All right, so this one, notice how all of these are 3's and all of these are negative 1's. Okay, so let's determine they're all the same inequalities. So this is where that little worksheet that I gave you comes into play. Okay, so they're all the same formulas. Now we just need to figure out, is it going to be a dotted line or is it going to be a solid? So the dotted line has negative 3 as the y-intercept. And remember, this and this are dotted. This and this are solid. So, is the one with 3 a solid or dashed? Well, it's a dashed line. So it needs to have one of these. So it can't be this one, and it can't be this one. So it's either this or this. Now I need to determine, do I shade up or shade down? So this dotted line is shaded down. So the dotted line is shaded down. So which one's shade down? Is it greater than or it's less than? It would be less than. So far, the only correct answers are going to be in this row. Alright? So now we got to determine, what about the next one? So the next one is a solid line. Remember, solid lines have the line underneath it. So it's definitely not this one. And it's definitely not this one. So I now have a 50-50 shot. Do I shade above, which is this sign, or do I shade below, which is this sign? So let's see, where did it shade? Did it shade above or shade below? It shaded above. And remember, shade above is this one, so this is the correct answer. This and this are the correct. Okay, that one's a little bit more trickier. I understand on that end. Okay, let's move on. All right, number 13, consider the following system of equations. Equation 1 is x plus 2y equals 6. Equation 2 is negative x plus 3y equals negative 6. Select the best description for each point. Alright, so they have equation 1, equation 2, the system of equations, and neither equation. Then they have ordered pairs. Alright, there's a very easy way to do this. All we are going to do is plug in these ordered pairs and see if it gives us the answer of 6 or negative 6. Alright, so let's do the first one. Negative 2 for x, remember, because x is our first, y is our second. So all I'm going to do are plug in these for x's and these for y's. And if it gives me the answer of 6, it is a solution. Alright, so once again, negative 2 is going in for x. So go ahead and put negative 2 plus 2. Instead of y, I'm going to put 4 equals 6. So what is 2 times 4? That's 8 plus negative 2. Well, I had $8. I let $2 go away. I'm left with $6. So is that a true statement? 6 equals 6? Yes. So this works with equation 1 so far. Now let's see if it works for equation 2. So instead of x, it's going to be negative 2. So negative and then negative 2 plus 3 times 4 equals 6. So negative 2 times negative 2 is positive 4. Or sorry, I messed up. Negative times a negative is a positive, so it's a positive 2. Sorry. Plus 3 times 4. 3 times 4 is 12 equals 6. So this is not a true statement. So my answer is only for equation 1. Alright, let's try 9 and 1, doing the same exact thing we just did. So I'm going to do this a little bit above. So 9 plus 2 times 1 equals 6. Already I can do this in my head and already know that 2 times 1 is 2. 2 plus 9 does not give me 6. So this does not work with equation 1. Alright, let's see if it works with equation 2. So put a negative, and then instead of x, it's going to be 9 plus 3 times 1 equals negative 6. So 3 times 1 is 3. Negative 9 plus 3. So I owe somebody $9, but I paid them $3. How much money do I owe them? I owe them negative $6. So this is a true statement, so it works with equation 2 only. Alright, our last one, 6 and 0. So again, I plug in 6 for x, 0 for y. So let's do equation 1. 6 plus 2, instead of y, I'm going to put 0 equals 6. I can do this in my head. 2 times 0 is 0. Plus is 6. 6 plus 0 is 6. That is a true statement. So this works with equation 1. Let's see if it works with equation 2. So equation 2 is negative x. So negative, and then put your x, 6, plus 3 times 0. And it should equal negative 6. So negative 6 times, plus 3 times 0. 3 times 0 is 0. Plus negative 6. Does negative 6 plus 0 equal negative 6? Yes. Notice they work for both of them, right? 1 and 2. So this right here is the system of equations. So it's 1, 2, and 3. Alright. Let's move on to 14. Which of the following system of inequalities represents the graph? Okay. So first of all, let's try this one. My y-intercept for this one is 4. So there's a y-intercept of 4 here. But notice that this y-intercept is a solid line. This is not a solid line. So F is wrong already. Okay. Look at this one. This one has 4 and 2x. And it has a line underneath it. So let's see. My rise would be 2, So 1, 2 over 1. So far, this works. Let's see about the next one. The next one does not have it has a dashed line, which is good so far, but it doesn't have it in y equals mx plus b. How do I move this x over? Let's add x to both sides. That leaves you with y is less than 2 plus x. So this one has a y-intercept of 2. So y-intercept of 2 would be right here, with a slope of 1 over 1. So 1, go up 1 over 1. Okay, so that one didn't work. So H is wrong. Okay, but at least we found our new equation right here. Let's try this one, G. Let's go ahead and put the one in slope-intercept form already. So my slope-intercept starts at 2. So right here, it is a dashed line because there's no line underneath it. And then it goes down 1 over 1. Sorry. Down 1 over 1. That works. Down 1 over 1 down. So see how that's working? Every point that I do, it's working. So far, this is good. Now let's get this in slope-intercept form. So I'm minus 2x, giving me negative y greater than or equal to 4 minus 2x. Divide everything by negative 1, giving you an answer of y. Flip your sign, negative 4 plus 2x. So negative 4 is down here, and this does not work. So the only answer is I, and there you go. Okay, 15. You are planning the menu for your restaurant. Each evening, you offer 2 different meals and have at least 235 customers. For Saturday night, you plan to offer roast beef and curry chicken. The beef costs you $6 per serving, and the chicken costs you $4 per serving. You have a budget of at most $1,100 for Saturday night. Write a system of linear inequalities that shows the various numbers of roast beef and teriyaki chicken meals you could make for Saturday night. Let X represent the beef dinners, so this is really important, X represent the beef dinners, and Y represent the chicken dinners. Alright, so we got to create 2. All we are doing is putting numbers in here, and that is it. So you are planning a menu for your restaurant. So these 2 are going to be the 2 different menus. Okay, you have at least 235 customers. So at least, you could have more, but you could have less. Sorry, you could have more than that. So this means 235 needs to be the largest number. Notice that I chose this one because the bigger number always gets eaten, right? So 235 has to be, because it's at least 235. Okay? For Saturday night, you plan to offer roast beef and curry chicken. The beef costs $6 per serving. Okay? So remember, beef stands for X. So 6X plus, how much is your chicken? 4Y. And it can't go over 1,100. Okay? The beef costs $6 per serving, and the chicken costs $4, and the most you can serve is 1,100. Okay? This right here is just going to be 1x plus 1y equals 235. Because we don't know how many guests we're going to have, and we don't know how many y guests are going to eat the chicken or the dinners, but the most we can have is 235. Alright? Okay, that is it, guys. So please study this video as much as you can. Currently, the district average is a 50. We need to do better than that. And there's no reason why we can't get half of these questions correct, especially after me doing a whole video on how to do the study guide. All right, good luck and study.